The other items, we're thinking about starting like a community repository on the SimPEG organization, and this could just be a place to keep track of sort of like where all of our communication channels, when we use the like Google group mailing list, where the Slack link is, all of that kind of stuff. Also, like the other thing I was thinking of this morning is even keeping track of like sort of some standard emails that we often send out. Like if you get a question from somebody, we probably want to get them on the mailing list ASAP, because that way everything is tracked. Otherwise, you're doing all of this work to get somebody onboarded, and then that's for a single person, and that's lost. So if we just have like a standard email that like can easily be adapted, that basically says, "Hey, direct your questions to the mailing list," that would be a useful thing. So we can chat about that as well. Are there any other items that people have on the lists? No?
That's a lot.
Yeah.
That's enough.
Fair enough. Anybody online? You guys have items? No? Okay. Then let's start with RFG.
Okay.
I think both have a presentation like the Google Drive repository.
Do you want to just join the hangout?
Yes.
I can let you drive.
I put on Slack the full program, the PDF version. So if you guys see talks that you want to, I'll be there. We'll be there. If you want, if you see something that you would like to hear, we can always report back. There's a lot, man. It's a huge program.
Yeah, it's very wide.
Sorry, Dom, I missed that. What did you say you put on Slack?
It's the technical program. So all the talks.
Oh, I see. Okay.
PDF. It's huge, massive. So yeah, if you see something in there, we can try to arrange to get there.
Okay.
Yeah.
That's in the meetings channel on Slack.
Oh, I can move it. Yeah.
That's fine.
If we start with you want to start as you like in the program, Dom giving the presentation, and I'm right after you.
Yeah, that's nice.
Yeah, which is a very nice configuration.
I guess so. Yeah. Okay. Let me then. Yeah, see this. Yeah.
Can everybody see Dom's screen?
On the small.
Just on a small item here.
If you click on him.
Oh, okay. Got
it. That works.
Perfect.
Yeah, so I'm not done this, but I basically grabbing everything from all the other presentations and putting them in. Because I'm first and the focus is really on SimPEG, I thought I would spend more time on what we are, what we're trying to do, what we're trying to achieve. And then at the end is the revive the GeoSci.xyz case study that we presented at BCGS. And then just finish with how to connect with us, with the Slack channels and all that. So I think the audience is going to be very like non-computer oriented. It's going to be very either academic or applied. So I thought I would define some of the concepts of what does it mean to be open source, in terms of downloadable and shareable. Everybody's contributing to it. So yeah, sort of give an overview of who we are. We asked Joe, so we need like a few more contributors here. Joe and then
and Dieter
Franklin.
And Franklin. John, if you have a picture, we'd be happy to add you to the contributors list as well. Yeah, so feel free to just send one along and we'll add that. And Dequan, you as well.
We're not there, so
anybody who is not currently on the SimPEG site and would like to be, send me a square picture of yourself.
What is the resolution?
Hopefully decent resolution.
No limit.
And then after that, it's what it means. What is SimPEG in terms of the framework? So building blocks, right? So you don't need to be an expert in everything. That's what I'll try to emphasize here. That you could just be either an end user to wrap like a script for them, and then they can run it, or if they're an expert in one specific field, then they can They can tackle one problem at a time. And then what is it? And the first one is simulation. So forward modeling, be able to see fields, to be able to write the physics and math, you know, like write code like math, and then be able to to use all the Python stack to be able to see things. And then the inversion, go from data to, that's you, Sag, thank you. I didn't ask permission. Great pictures. And then it's in Python, so because it's in Python, we can leverage so much of the ecosystem. And whoever is in geoscience should be aware of that, because there's a lot of free stuff out there. And then we are in geophysics, and then the goal is to be able to bring everything together, all the different physics, and that's kind of a unique package for this, is that everything is easily exchangeable between different physical properties. Then I'll dive into the GeoSci.xyz, show the data. I'll just do the PFs for this one. And then I'll run some inversions, show some inversion pictures, talk about that. And then what's next here, I'm kind of open. I would like to just put some of what you guys are working on. So if you have anything you would like me to go over, I'll add like one picture from my stuff, but that's kind of a placeholder right now. And then I can introduce, I'll introduce with the next talk for Thibaut. It's going to be the ecological constraints. And then finish up with a slide where all the places that they can reach us or install. That would be the talk.
How long do you have for the presentation?
12 minutes.
Short. 12 minutes,
Oh, that's
okay.
short.
Yeah.
Short.
Very true.
Just a couple like general thoughts. Well, first we need to fix the slack length, but that's fine. It might be nice to show the DC part of GeoSci.xyz as well, even if you don't necessarily go through it. Like, I think that was one thing that people got really excited about at BCGS, was just being able to see the currents and use this as like a forward modeling survey design tool. Because right now, sort of just the example of the block in a half space, it's a bit of a vanilla example, and so that probably like won't resonate with most people.
Yeah. Yeah, that's a good idea. So I'll just use the pictures. Yeah.
Yeah, and I would try and like, even wherever possible early on, even though like it is sort of general, trying to bring it to problems that people care about. So you like, one thing you could even start with, and this might be kind of cool, is to sort of bookend it with GeoSci.xyz. So even though you're not talking about it all that much, it's like, it's a motivation. It's a really good like motivating problem, because it is multi-physics. We can tackle most of the different physics that we're looking at. There's some subtleties with the remnant magnetization and all these kinds of things. So there's a lot of interesting questions. And so that might be like just
posing the challenges like in general.
Yeah.
What you're up against. I think that would be nice to show first, and how SimPEG can help. Because we're not going to solve a problem, but there's tools that can help those problems.
Yeah.
So I think that's it.
Yeah, because you want to like develop that need before you.
What's the title of the section that you're in, Dom?
I think it's education. And 1 second, I'll pull it up here. We are in minerals. No, that's not me. We are in Earth 1, geophysical exploration. Yeah, I'm not too sure that it means.
I put it in the blog yesterday.
We are in the Earth. I think it's Earth exploration in general, I think.
Okay.
Your E8, your geophysical exploration methods.
Yeah, so then having your GeoSci.xyz as a sort of an introductory and motivator thing with respect to, not only potential fields, but electromagnetic methods or anything that might actually resonate more with people.
Okay, sounds good. Yep, good idea. I'll put it here after the intro slide, I guess.
Actually, I would do it first.
Like here.
Yeah, because you want to state the need, and then because that gives context for where we fit in. Otherwise, it's just sort of like we have all of these tools and da 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 da.
Gotcha.
One presentation, I think Rowan has a couple of presentations that he started with looking at the groundwater side of things and then drilling into SimPEG. So there might be some flow ideas in there.
You
that's
remember
SciPy 16 or 17. Maybe 16. Yeah, there's
Okay.
something backwards.
Oh yeah,
I don't
that,
know exactly what the title.
Yeah. Okay. I shall. I see.
And that was you probably don't need to go to that level of
Got it.
detail, but something like that.
Boogie.
Is there anything from I don't know, any other images you need or things you want us to check out with respect to the presentation, or
Well, yeah. If you guys wanna put something for what's next in the what's next section,
Okay.
If you guys want to add some exposure on what you're working on, just send me a blip. I'll add it.
But 12 minutes is kind of short, so not
Yeah.
sure. Well, probably like a kind of gallery slide,
Yeah.
just showing kind of whole spectrum.
Yeah.
Other than that, I think you may not have any comments actually.
No, that's it. Just things that might excite people's brain.
You can draw this. These might be slightly out of date, but I gave a presentation at Colorado School of Mines and then at Calgary, and in there I had sort of a slide on each of the different methods and just sort of a somewhat research application. So you might be able to draw some images from there, because then it just shows that and somebody is actually applying the MT code to research and the DC code, etc. Yeah, but I wouldn't be afraid to try and carve out a little more time for the Kivitsa stuff, even if it is a bit brief. It carries more weight if there actually is a real problem.
Yeah.
Well, maybe even posing our questions about Kivitsa, what's the problem, what are the interesting geological units that we want to characterize? I think that kind of really motivates people. Those are a problem. And I think there are two aspects where a third DC can show flexibility to show the fields to understand the physics. And then with the MAG, you can probably show the inversion aspect. We can invert that. Or you can emphasize a random magnetization or something like that. I think you could have at least two kind of strong points. Yeah, I think that's probably what we did for that ECG as well.
Yeah, but that was way longer talk, right? If we start getting into that geology, man, that's a 20-minute talk on its own.
But even picking a single problem like the remnant mag, just maybe rapid fire through a lot of the problems. Because I wouldn't be surprised if some of the audience is familiar with Kivitsa.
Yeah, we don't really know, man.
But I mean, even if you generally speak to just a whole swack of interesting research problems, and then say
pick one.
This is some of the things that we're trying to be able to investigate with SimPEG. Here's one problem that I've been connected with, and talk through remnant mag a little bit. Yeah, because I think it's important to show that we can solve
a real problem.
A real problem.
Sounds good. More to come. T.
Yeah. So. Awesome. So I'm a bit at the same stage as Dom. It's still working on the presentation. It's so, but like really, what I was working on right now is like the focus and trying to focus like more of my work around the TKC example and don't dive too much into the technical details that really like show what we can achieve with that framework. So start by tying up with the Dom's presentation that all this work is powered by SimPEG and that we benefit from all the work done by the other people for the forward modeling of inversion and sensitivity, etc. And our objective for this presentation will be to try to tie together geophysical, petrophysical, and geological data in a single inversion framework, so like that the final model can benefit from all type of data. And so what's what has been nice about the SimPEG framework is that everything is separated and it's kind of like its own sub-module or sub-package, and that most of our work is just in that regularization sub-package. Like, so we can benefit from survey and problem and data misfit all the same, and we don't have to redo everything. We just have to work in that regularization thing. So we will go through this work through the TKC kimberlite example. So that's the geological synthetic geological model we have from that diamantiferous deposit. And usually that's like, so that will be like our starting setup for a Tikhonov style inversion, that we have discretized our model, we have assigned some physical properties, and we have gravity and magnetic data. And when we invert that with our either SimPEG or UBC code, that's what we get out. So we have an idea there. We can have some idea of the extent of the bodies, but we definitely don't get the distinction between the PK unit and VK. And so the framework we propose here is that framework. So that in red here, it's like the usual Tikhonov style inversion. And what we're gonna add here is the petrophysical and the geological data. So you see that it's after each iteration of the inversion, we're gonna add this information back into the geophysical inversion. And for that, we use a Gaussian mixture representation of our physical properties. So for example, here, like I imagine that I have two physical properties with two types of rock, and so that we can distinguish them in in this physical property space. And what we do next here actually is that we're gonna actually classify after each iteration our geophysical model based on that on our prior petrophysical distribution. So it looks a bit like this. In blue here we have the geophysical geophysical model at a certain iteration. In gray we have the what we think the petrophysical distribution should look like, and in black is going to be a sort of like an average between the two to push the inversion towards that distribution. And what it ends up looking like in the algorithm, if you're familiar with it, is basically we're updating the smallness weight and the reference model at each iteration. So I have an example on a very simple example here, where like on the left we have the Tikhonov style inversion, and on the right petrophysically constrained, and the blue dashed line is actually my reference model. So you see that for the petrophysically constrained, at each iteration we're changing the reference model to guide it towards a more clustered solution that reproduce our petrophysical data. So back to the TKC, we can add this type of the information we can have about the petrophysics into the inversion. So now I have still the gravity and the magnetic data, but in the algorithm I also feed it a petrophysical distribution for density and for magnetic susceptibility. And that's the step we get after that. So we see we have like a much better defined body, but we still definitely don't recover well like this very high susceptible unit here in the mag, and the gravity we see we have some sort of like a halo things going on, and the volume I also don't match between the two inversions. So what's nice about the petrophysics is that we're able to tie together the two type of inversion. So the solution is then to go to a joint thing. So instead of having two distributions separate for density and magnetic susceptibility, we tie them in a 2D distribution like this one, and to jointly invert the two data set. And that's when we get finally a more dramatic gain in the inversion side. So that's the model we recover for the mag and gravity, and that's the kind of geological model we can infer from this inversion. So we finally able to recover the VK unit, and we also have like some features such as like this protuberance in the east here. And what I still want to run these things, but starting from this model, I want to like add like maybe a single borehole here, and I'm able to constrain on the lithology themselves, saying that certain cells should belong to a certain cluster. So not assigning like petrophysical constraint or like bounds, but saying that, oh, this cell should belong to that type of rock unit. So that's what I will call for like here for the geology data, that we're gonna constrain on the lithology themselves. And after that, so a bit like dumb slide, like what's next. So one of our goal here is also to release this type of code to the community. It's not something that we're gonna have inside here, or that's only a certain lab will have access. It's gonna be an open source one, and we're gonna release it with example, and also for reproducibility to release a case study we're gonna do with this code. And then also what's next is that I think we've done a pretty good job at constraining the petrophysics, and now it's more about all the geology side of constraint that we can really improve the classification. So it's just like a few examples that I have here where like I will see how I organize that, but basically this example, like it's a silly example saying that I don't want the resistive unit to touch the background, so it actually enclose it into the conductive unit. But I can use that also for like here a time domain EM example where I have a resistive layer between two conductive ones, so I can impose that type of things. Or here should probably put it bigger, but that's this one is like it's like more an hydrogeology example where I actually constrain the classifications that I want the dry stuff to be on top, the fresh water to be in the middle, and the salt water to be at the bottom. And I can actually put that type of constraint. And that helps also a lot the inversion. And that's also one way also you can get some geostatistic tools in it, because if you have few drill hole and people have done like a bridging around to get an idea of the depths, that's an information you can add to constrain that type of stuff. Or we can also take into account nonlinear relationship and cluster between physical properties. So here, like we have this normal Gaussian, but you can have like quadratic or whatever type of polynomial you want. So yeah, so that's the stage I'm at right now.
Yeah.
Oh yeah, no, I have to work on that. Yeah.
Can you flip back?
Sure. Which one?
Just sort of new. So we talked about, because the thing I want to make sure that doesn't get lost is stating the problem and what's new.
Mm-hmm.
You've got a lot of details coming
Yes.
in, and so that's going to be hard for people to potentially get through. But yeah, like I guess stating what is the state of the art, and what are the types of problems that could really be captured before this.
Yeah.
And what is the new thing that you're taking out? So I guess just like stating the, make sure you state the problem.
Yeah, I can.
And then you probably don't have to talk too much about the SimPEG framework.
Yeah.
Because
Yeah.
we already talked about it.
Okay.
So like, it's up to you, but like you might not even need to slide on it.
Yes. Okay.
At least if we're again, but
You have a slide that shows, like you got one that shows the true model and then what you recovered with your new one. I think the big impact is true model and then what you get with the L2 inversion, and then you see what you get. When you see all three of them in a row, you go, oh yeah, these two look so much more alike than the one in the middle.
Yeah, like I have a picture like that, but I did not think. Like you want to be something like this one on the right. So like I have like the L2, the singly physical constraint and the joint constraint.
Yeah, that's super.
Like that's that's kind of like the summary of the world.
Yeah, I mean, but that one image in itself is like the mic drop.
Yeah.
Moment.
I would get to almost draw the workflows.
Yeah, it's a tough one.
drop or like significantly simplify. Because it might be worth having some points that you can speak to of like what's going on.
Yeah.
Yeah, that's complicated.
Yes.
It's great for a paper, but
yeah, I admit that I put the slide yesterday night, so I was like grabbing things as you like grabbing things from old stuff, but yeah, I agree. It's I don't have time to introduce any of this. So maybe focus on really on the story of TKC, like.
I personally think that the slide that you're focusing and I'm more going to focus here. It's a nice tie-in with my presentation.
Yeah.
Which one?
Let's say there's on slide 5. I would definitely keep it because it kind of refreshes the idea of like modularity.
Yeah.
I mean, that could be a nice connection.
Oh yeah, if you want to save time.
Yeah, right now I just want the main focus was okay. What's the starting point and what's the flow? So I guess the TKC example would be as you use GeoSci, you use TKC just to tell the story.
Yeah. Yeah.
Any other comments?
I think at the end, can you go really down to a conclusion?
Yeah, I don't have really a conclusion right now, but
what was that before? What's next?
Oh yeah.
Where was the?
I had this final.
No, not that one. So.
This one.
Yeah. So can you say what do you want to say here? Like, can you do it again? Here.
Like on the next thing, there is there is two sides. There is like the open source community side that we want this code to go out and be usable by other people. It's not something we're gonna keep in-house. So here, something that we really want to broadcast and advertise. And then there is like the research part where we want to improve a lot how you can like very complex type of constraint for the geology to put more up your information.
I think I would like to really emphasize that like before SimPEG talking about communities and like how it helped, like I would emphasize what you've really done, because that's a big generic challenge in geoscience.
Mm-hmm.
How do we really integrate information? How do we put the known geological information into your inversion? I think that's a pretty big topic, and I think that's what you've done. So I think I would really comment that first, and then you can comment about how SimPEG helped you to do that. I think that's a bit more powerful rather than like starting from SimPEG and talking about that.
Okay, yeah.
One thing you could do sort of similar to that is almost like bookend with the image that Dom pointed out, where you have the box drawn around the regularization and basically say this is where we're going to focus. And then even just add arrows that talk about the pieces that you're changing there. So you're including information by updating, you're changing MRF every iteration and those kinds of things. And so like it's a much more conceptual diagram. Do you know what I mean?
Yeah, okay, so like you still have the box around regularization, and then you show basically the class of function you are working on?
No, you show the word.
Yeah.
So like if you go maybe to your complicated workflow diagram.
Yeah.
Yes. Right, so there's some interesting things that come in, and so like actually even just drawing, like using some of those terms and annotating the other diagram, so that you have that like terminology to refer to. Because I think that's definitely valuable and it gives context and like shows that you did something very tangible. But then also sort of fits it into the SimPEG framework.
So you will keep that framework, but basically tie into the
Well, not this framework.
Yeah,
but the terms from it. So keep the words that and like keep the words that are important for you, and then just sort of annotate where that's coming on the SimPEG.
Okay.
And I think at the end I would make a big deal about what you've because there are two things, right? Solving each problem is very challenging, right? Mm-hmm. I think it's probably a more than one PhD work, right? Like actually like solving a gravity problem, MAC problem, EM problem. It's tough, right? Yeah. But that part is like, not really done. We're moving on, so it's kind of done. So like so that's where you can build upon, and because like joint inversion itself, it's also challenging. But we really need all of those pieces to do that. So I think I would make a big deal about that, because that's actually like
basically like that the fact that we're building on top of.
Yeah, we're moving forward in that way.
Yeah.
Because that makes the SimPEG really powerful, I guess, and then you can actually really emphasize that in your talk, I guess.
Yeah. So that basically we use the work that Dom is doing on the potential fields that we can include it directly.
Well, like there are multi-figs already plugged in. Yeah. So you can your joint inversion framework can actually handle for instance EM and whatever MAC gravity, something like that. Okay. You don't really need to show that, but you can actually just comment that.
Okay.
You already started doing it when you're showing the TEM and the frequency domain, right? You have the 1D inversions. So that's kind of the idea. You can touch them all if you wanted to.
Yeah. 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 Any method that is in SimPEG, basically.
Mm-hmm.
Yeah, which is huge.
Yeah, it's true. The joint part is kind of an undertone that you're not really mentioning, but it's actually really
you're gonna just open-end it, but there are multiple problems that you can actually do a joint inversion with this framework, which is actually pretty big, I guess. So I think I would kind of open-end. Cool.
Any other comments, questions for Thibaut?
I guess I've got one comment. I was just wondering, sort of at the beginning, where you're kind of introducing the challenge of really working with different rocks and rock properties. If you were going to introduce TKC at the beginning, where you have, but if maybe there was a table. Basically saying, rock 1, 2, 3, 4, and then, maybe physical properties, density, susceptibility. First of all, just with a number or maybe a range of numbers, which is kind of what people would generally see, and then, kind of have another image that kind of goes from, say, well, it's not really just a number, a range of numbers, it's really a distribution. And then if you looked at density of these different rocks, you'd have, some, function with a whole bunch of peaks. And to use that as also a little bit of a motivator to say, what I'm up against. I mean, how do I incorporate all of this sort of probabilistic information about the properties and the different rocks? How do I put that all into one package?
Yeah, I did not say, I think, a single time the probability word. Like I was a bit afraid to introduce that, but
you do show.
I do show.
You do show PDFs later on, right? And then you're talking about So there you go.
Yeah. So
anyway, I just thought you might sort of open that up a little bit more right at the beginning, and then just toss that out as a challenge. Like, okay, how do I do this? And here's where okay, I can invert each of these data sets individually, but really I've got all this other information. I want to incorporate that and find something, a solution that's compatible with that.
Yeah. A lot of things to put in.
Yeah. So then once they're there, then you just have to decide what has to get omitted, and what basically just flashes up as a complicated diagram in which you only have 10 or 15 seconds to point out one thing and just illustrate that, okay, it's a process. It's non-trivial. I'm not going to work through this.
Okay.
So maybe we can even spend just a bit of next meeting finalizing, polishing, chatting through any last things on these. Mike, did you want to chat about anything with your poster, or?
I don't really have a draft yet done.
Okay.
Or in any shape or form. I don't think I'm going to focus too much on the SimPEG framework or anything, but I'm just going to kind of go through that survey design aspects for the underground environment. Show some of the challenges and how we're starting to try to address them, and then just kind of discuss how SimPEG has been a great tool to use to kind of do that work. So,
okay, then we will do that next week. One of the things, so are you guys good if we move on?
Yes.
Cool. Any other comments, questions before we move on? So the idea of starting a community repository in SimPEG. So there's a few things that we don't really have yet, even within SimPEG or Discretize. We don't have things like a contributor guide. A lot of projects have a code of conduct, which isn't necessarily for a small group, it's not as necessary, but once you start to get to a bigger group, it's really nice to just have something documented to point to. So if somebody is a bad actor or whatever in an email list or anything like that, we can see that there's an agreed upon set of standards within our community. I posted a couple links in the Slack message, and I can circulate them to you afterwards, just on some ideas. Leo has some really nice ones in Fabiano that we can basically just go and adapt. It's all open source. Yeah, the other thing is like keeping track of communication channels, because we have Slack, we have the mailing list, and we have like newsletters. So newsletters are sort of one-way communication, right? Like we send out a MailChimp newsletter, you'll email back to that. But both Slack and the mailing list are two-way communication. And then there is also sort of getting emails personally, which I think like, for all of our sakes, we should try as much as we can to move away from that. I mean, if you are sort of collaborating with somebody one-on-one, like, yeah, absolutely. But if there is just somebody who's emailing you with very generic questions, let's try and get all that stuff to the mailing list. Because then later on, when somebody asks you the very basic questions, we can then just point them to that thread rather than like repeating these upstarting conversations over.
So your mailing list is a Google
Yeah.
group?
Yeah. And so with that, one thing I'd appreciate is like if a few of us can just make a habit of checking it once a week. Because I know like the emails come through and you see it if it's sort of on your radar, but sometimes, and I'm very guilty of this, like you see the mailing list thing come through, it's like, oh, I'll deal with it later, somebody else will deal with it. But then there was a message that was like a very basic, very answerable question that was there since February, and we just like dropped the ball on it. And so, yeah, so if like a few of us could sort of just make a habit of checking that regularly, and even if you don't know the answer or don't have the time, like if you can ping even on Slack and just say like, hey, nobody's answered this in a week, somebody take it.
Is there a possibility that we can, weaponize the brains of the other users? So instead of us answering all the questions, there's just sort of a community. So another SimPEG user might be able to answer the question of the first SimPEG user. We don't even have to.
Yeah, absolutely. But I think that like starts by us growing the mailing list base.
Yeah, fair enough.
Because if we'll be on there, then the natural thing to do is email us personally. Yeah. So keeping track of some of those things in the community repo, and I think too, like as the group gets, like as the contributor base gets larger, and as people start moving to different locations, it would be good, I think, to document like decision-making process and the pull request process and things like that. Because right now, like we've decided that you can branch directly off of master, and then we do pull requests on a master. So everything, it's a very short release cycle. But then, like, what does that actually mean? So when you generate a pull request to master, we should document there's going to be a review process, and that, like, here's a few of the things that we look for. Generally, we ask that only sort of 4 contributors merge, because we need to then also like off the version and send out a release. And so just so that that's documented, I know that we are all basically aware of that, but yeah, we have to know that. And then same thing with like where our examples and stuff are, because right now they're all over the place, and that's fine actually, as long as it's documented. And then later down the road, we can start to organize it more. But just to know where all the things are.
The mailing link is basically there for people that cannot contact us either on Slack or post an issue on GitHub. That's.
I think it serves a bit of a different purpose. And why I say this is because I've been following sort of some of the Jupyter mailing lists, and so often those will include just like interesting things that might be of interest to the community. So somebody will say like, hey, did you see this really cool package that just came out using Jupyter to do X, Y, and Z? So it is sort of a asynchronous community thing.
Okay.
So Slack is good at real-time communication. It's not necessarily great at like archiving and asynchronous communication. So like one thing I'd like to see us start doing is sending out release notes to the mailing list.
Okay.
So when a new release comes out, we send that out. Yeah, and then you can start using that as a communication channel between us. If you just see an interesting article or something to think about that like we as a community should think about, that's a good place to do it.
Right. Rather than Slack, or we could do both.
Yeah. Like I think the mailing list sort of prompts you to construct a
Right.
like thoughts more so than Slack does, and so that's sort of the separation.
Yeah, just a switchability like the meeting.
Any other comments or questions on that?
So currently, are we getting an email? Like if there's something uploaded from Google Groups, do we need to do something to get an email about that, or is it?
Pretty sure I do not get them. Yeah.
Yes, I think I'm not getting an email.
Well, did you get the one that you got the one that I sent about the
Constraint.
Yeah.
So, but I think I got it from because you replied. I think I haven't got it. Like I haven't got his email. Like when he uploaded, I guess.
I think you should have. If you dig back in your email, I mean from February, because I didn't reply to you. I replied to the mailing list. So like when I hit reply.
Like I
So
saw.
if you didn't get that, then either you're not signed up for the mailing list, or your settings are such that you don't get.
I'm not signed up for the mailing. I think I saw it because you posted it on Slack or something.
Okay, I'll post it again.
So
Okay.
yeah, we need to register to the mailing list. I don't think we're registered by default.
Oh, I think I did sign that. Anyway, I'll figure it out.
With current pull requests, I don't think there's too much to go over. Joe's PR is still sitting there. There's only one thing I want to clarify with him, and I think he's still made it school. It's just if there's like compiled files that we can remove from there and get the user to build it. Once that's in, we can build it. And yeah, was there anything else?
Desk was cool. I'm gonna keep working on desk realization.
Right, that was cool. Yeah, so Dieter helped me a lot for SimPEG EMLD. So it's actually pretty good, in pretty good shape. So I was back like working hand with him a couple of weeks ago, back and forth. So both packages kind of updated.
Nice.
Yeah, it's actually nice to work with him. It was a kind of, I think that's an ideal experience. So it's kind of connected now. So I'm using the package. Well, he's not using SimPEG EMLD on his end. But I think what he wants to do, like he wants to kind of revamp, well, at one point, like use EMPyMod as an inversion tool as well, which will be, I think we've started that portion. I think there are more pieces that can come. And well, he's excited to do that as well. Like on his end, he's doing postdocs. Netherlands University.
Delft, right?
Delft, yes. So he's going to Delft, working with, what's his name? Everslaw. So it'll be interesting.
On that note, I mean, if there are people who are interested in jumping on the EMPyMod inversion, just let me know, because it's actually started and it's very clear what needs to be done next. I just haven't had time, so I'm very happy about working.
Yeah, I think the Marine EM, it could be an interesting application for that. So, which we haven't really done.
What was this comment this morning about utilities? I couldn't figure out where.
Oh, so he wrote, it's a cool little util that displays which packages and which versions you have. So and it prints it nicely in the notebook. So it's like super handy for distributing research notebooks, because then you can just say like I was on SciPy 0.6.2, SimPEG 0.2. Yeah, so it just prints requirements.
Yeah, and Joe did the Quatrian version. Have you guys seen that? That's actually, I was pretty excited. That's really cool. So that's 2D.
Yeah.
So he actually hooked up that Quatri to a DC problem. like 2D basic problem, and ran that, used that for his field at school with his kids, I guess. Which I thought really cool, and that's kind of ideal use that we would want, I guess. So it's exciting. That's kind of
Okay, well, any other comments, questions, thoughts before we wrap up?
not really. Dequan, can I meet you after this meeting? I got a couple of questions for a 1EM workshop. I'm just working on the inverted conductive sphere. Just having a hard problem. Like it's always happening. This donut. So
Okay.
I got a couple of questions. I kind of want to just chat with you after this.
Okay, that's fine. Yeah. Okay.
Perfect. Okay. Well, thanks everyone.
Thanks, Lindsay. Bye, guys.
Thanks, everyone.
The Sogi.